Hello, good day. In this tutorial video, you will learn about the rules of replacement. So there are instances that we can prove argument using the 10 rules of inference only. So we need another rule, and rules of replacement is of great help for us to prove those arguments. So let us proceed now to study this rule. The first rule is the double negation. Double negation states that any proposition is equivalent to the negation of its negation. So for instance, if we have P, then it is just equivalent to the negation of its negation. That is the double negation. The next rule is the associative law, and this law states that the grouping of the component parts of a conjunction or a disjunction, for instance, and we have disjunction and conjunction, may be altered without change in truth values of the statements. So as you notice here, in this statement, P or Q is grouped, okay, is grouped as one, and it was regrouped into Q or R. And same also with the conjunction, P and Q is grouped as one, but it is just equivalent when we regroup it using Q and R. So the truth values of these two statements are just the same. The next rule is the commutative law. So in this rule, it states that the order of the constituent parts of conjoined or disjoint statements may be reversed. If for instance we have P and Q, it's just the same with Q and P. And P or Q, just the same with Q or P. Okay? Next is the tautology law, or sometimes called idempotent law. So in this law, it states that the conjunction or the disjunction of the same statements is equivalent to that statement. For instance, P and P, same with P. P or P, same also with the statement itself, P. The next rule is the law of exportation. And this law states that a conditional statement whose antecedent is a conjunction, okay, is equivalent to a conditional statement whose consequence is also a conditional. Okay, take note of that, and that is the law of exportation. Next rule is the law of transposition, or it's sometimes called the contrapositive law. Now in this statement or in this law, we have a conditional statement, P implies Q. It is just equivalent to the reverse of its constituent parts, provided that they are negated. Okay? As you notice here, this P implies Q are being reversed, and they are also negated. That's the law of transposition. Next is the De Morgan's law. So in the De Morgan's law, the negation of the conjunction is equivalent to the disjunction of its negated constituents. Okay, as you notice here, if we negate the conjunction of P and Q, it is just equivalent to the disjunction of their negation. Also, if we have a negation of disjunction, it is just equivalent to the conjunction of their negation. That's De Morgan's law. Next, it is the material implication, or the MI. So in this rule, it states that a conditional statement, for instance, P implies R, is just equivalent to the disjunction of its component provided that the antecedent, which is P, is negated. That's the material implication. But take note that we have P implies R. And if we're going to change it into using the material implication, it must be disjunction of its constituent part and the antecedent, in this case is P, is negated. That's material implication. Number 9 is the material equivalence. Here, we have a biconditional statement, and it is just equivalent to the conjunction of two conditional statements where the antecedent and the consequence of one is the consequence and antecedent of the other. Okay? Also, a biconditional statement is equivalent to disjunction of the conjunction of the two constituent parts and the conjunction of their negation. That is the material equivalence. Lastly, we have the distributive law or the DT, and this law states that a conjunction statement with a disjunction of two statements, another two statements, is equivalent to the disjunction of conjunctions. Okay? And also, a disjunction of a statement with a conjunction is equivalent to the conjunction of their disjunctions. That's the distributive law. Now let's have an example. So for instance, if horses fly or cows eat meat, then mosquito is the national insect. If mosquito is the national insect, then peanut butter tastes good on hot dog. But peanut tastes not good on hot dogs. Therefore, cows don't eat meat. Now our solution would be, we're going to symbolize each statement using any letter. So in this case, we're going to symbolize horses fly as F, cows eat meat as A, mosquito is the national insect as M, peanut butter tastes good on hot dogs. Now you know already the symbol for the operations. We have the disjunction, when to use the symbol for conjunction, the conditional statement, and the biconditional statement. Now the whole argument can be represented as this one, F or A implies M. That is actually our first statement. Now the second statement is another conditional statement because of the word if and then. So we have M implies P. And the last premise is but peanut tastes not good. It is just a negation of P. Okay? A negation of P, and our conclusion would be the negation of A. Now using the rules of inference and the rules of replacement, we can prove this argument using our proof, the formal proof. Now we're going to use this table, okay, for us to have a basis, okay, to systematize everything for the different steps and justifications. Now, we're going to have our fourth step here, And for us to have a conclusion or another premise, we're going to use the given premises. Now, as you notice here in premises 2 and 3, we can apply the modus tollens in order for us to arrive at not M. Now, using our premise number 4, which is not M, we can proceed to premise number 5, and using our premise 1 and premise 4, we can use the modus tollens again to arrive at a conclusion not F or A. Now, as you notice, this is a negation of disjunction. So therefore, if we have this form, we can change it into another form using the De Morgan's law. Now, using this rule, so we'll have a conclusion not F and not A. Now, whenever we have a conjunction of two different statements, then we can have we can get one of these two statements. Since our conclusion is not A, then we can get not A using simplification. Now, since we have arrived at our conclusion, then we are sure that the argument is valid. Okay, let's proceed to our second example. If I work, then I earn money, but if I am idle, then I enjoy myself. Now, our first premise can be symbolized as W implies M, and because of but, if implies an implication. If I am idle, we're going to use I, then I enjoy myself is E. Proceeding to our second premise, either I work or I am idle. So we're going to use disjunction. However, if I work, then there is a conditional statement again, then I do not enjoy myself. While indicates conjunction, if I am idle, then I do not earn conjunction. So therefore, in our third premise is a conjunction of two conditional statements. Now our conclusion, because of therefore, is I enjoy myself if and only if I do not earn money. Now we know that if and only if is a biconditional statement. So therefore, our symbol is E using a double-headed arrow. Then we have not M because of do not. Now again, using our formal proof, we have this table, and I have provided you already the different justifications and the steps here so that we can just arrive at the conclusion for each premise. Now given our three premises and the conclusion, in premise number 4, we're going to use 1 and 2 using constructive dilemma. So since we have W or I, and our premise 1 is a conjunction of two conditional statement, and given the disjunction of two antecedent here, then we can arrive at the conclusion that it must also a disjunction of their consequences. So we have M or E. Now for number 5, again we're going to use also constructive dilemma on 3 and 2. So same process on 1, say, we're going to apply it to 3. So using constructive dilemma, we're going to arrive at not E or not M. Now using our rule of replacement, which is the material implication for number 5, we can change this form into not E implies not M using MI. or material implication. Now, as you notice here, since we have two negation, a negation of a negation of E, then we can change this form into E implies not M using double negation on 6. Now again, for number 4, we can also change this form into this form using an implication, so it will become not M implies E. Now, using the conjunction, we can conjoin premises 7 and 8, so it will become E implies not M and not M implies E. Now take note that in this form, okay, since the antecedent of one statement becomes the consequence of the other conditional statement, and the consequence of one conditional statement becomes the antecedent of another conditional statement, then it must be E if and only if not M, using our material equivalence. Okay, so since we have arrived at our conclusion, therefore the argument is truly valid. Now let's have another example. Now at this time, the steps are not given and justifications also. So we have to identify the following justifications and other premises. Now using two premises here, and we have a conclusion which is the disjunction of G or E. Now, for our step number 3, we can use transposition for number 1. S implies G. When you say transposition, it's just the reverse of the two constituent parts, provided that we have to negate them. So this is our newly formed premise. As you notice, we can now use premises 2 and 3 to arrive at our statement number 4 using hypothetical syllogism. So we have not G implies E. Okay, using hypothetical syllogism, because the consequence of this and the antecedent of this conditional statement are just the same, so we can apply hypothetical syllogism to get not G implies E. Now, using material implication for number 4, we can change its form into not G or E. Okay? Now, since we have double negation here, we can change it into G or E. Now, as you notice, this is already our conclusion. Then, this whole argument, though it's not in a paragraph form, we are sure that this argument is valid. Now let's proceed to another example. So in this case, we have a simple statement for the conclusion, which is not E. Now for our premise number 4, okay, so by the way, our approach, my approach and your approach might be different. There's no single solution or step in proving an argument. Okay, take note of that. So for our premise number 4, so we have to analyze each premise given, okay, in order for us to have another conclusion using these 3. Now, when I take a look at number 3, which is not C, we have C in C for number 1. Now, in order for us to get this later on, I will add a statement here for premise premise number 3, and the statement that I will be adding to not C will be not D. Why? Because I will use De Morgan's law for number 4 in order to change its form into not C and D. Now take note that if we have not the disjunction of, or the negation of this of the conjunction of C and D, then I can apply this premise to premise number 1 rather, by using modus tollens to arrive at not A or B. And since again this is a negation of the disjunction, I can use again De Morgan's law, okay, in order for me to have a conjunction. And applying the De Morgan's law on number 6, it will become not A and not B. Since we have a conjunction here, then I can use simplification on number 7 to get not A. Why not A? Because I can use not A to premise number 2 using modus ponens to get E implies not E. And then, since we have a conditional statement, then I can use, or I can change its form into not E or not E using material implication. And take note that if we have a disjunction of the same statement, then it is just equivalent to its statement by using the law of tautology. Now, since we have arrived at our conclusion not E, therefore the whole argument is valid. Now let's proceed to the last example. So again, it is just similar to the previous example. Our conclusion is a simple statement which is a negation of T. Now as you notice that we can already apply, or we will not add any more statement for not O, because I can use, or we can use already 2 and 3 to come up with not P using modus tollens. Now since we have not P here, so we'll going to add what will be the statement to be added for not P. It must be not V. Okay, and then we're going to change its form for premise number 5 using De Morgan's law, or sorry, so we're going to use commutative law, since the the statement that appeared first here is B, so we'll just make it similar. So we're going to use commutative law first by changing the order of the two constituent parts here, so it will become not V or not P. So again, we will use De Morgan's law on number 6 to come up with the negation of conjunction. Okay, since we have negation here and we have a conditional statement, and the consequence is being negated in number 7, so we're going to negate also the consequence, or the antecedent rather, using modus tollens. So we'll have not T or C. So in order for us to arrive at not T, we'll have to use De Morgan's law on number 8, so that we'll have a negation of the two constituent parts and they are conjoined. Since we have conjunction, then we can get not T using simplification. So since we arrive at our conclusion, then the argument is valid. So this will be our last example in this tutorial video. I hope that you understand something on proving arguments using the 10 rules of inference and the 10 rules of replacement.